So in section 9.2, we're going to take a look at characteristics of quadratic functions. And our learning targets today are finding the zeros of a function. We'll talk about what those mean. And then finding the axis of symmetry of a parabola, which is essentially a line that is on our graph. And we're also going to take a close look, or not a close look, but a look into section 9.3 as well on how to graph parabolas. So we'll do a little bit of overlap into that section as well. For a quick warm-up, who uses quadratic functions? Well, quadratic functions can be used to find out where objects land. So for example, if I was launching a water balloon out of a launcher and I knew its trajectory, speed, I knew its starting point, and I knew the angle it was fired at, I could find out where that water balloon was going to land. Any projectile objects can be figured out as to where they're going to land. You can find maximum heights out as well. Quick warm-up for the intercepts. This goes back to section 5.2 if you recall. Finding an x-intercept. If you recall, we plug in 0 for y, and then we solve our equation for x. So I would add 3 to both sides and divide by 2. And I would see that my x-intercept would be 1.5 or 3/2. For the x-intercept, the second one, same kind of concept. Take 0 in for y, 3x plus 6, subtract 6, and negative 6 equals 3x divided by 3, and we get x equals negative 2. So my x-intercept would be negative 2. That means it crosses the x-axis at negative 2. And keep in mind, when you're finding the y value, it is always going to be 0 because when we are on the x-axis, our height is 0. So keep that in mind whenever we take a look at the rest of our slides. Now, in this problem, in this section, we're going to look at what we call a zero of a function. A zero of a function is essentially an x value that makes the function 0. It is also essentially the x-intercept. So wherever your graph crosses your x-axis, that is representative of your 0 of your function. So if they give you a graph, you are able to find the intercept, the 0 of the function, very easily. Quickly addressing this, how many zeros can there be? Well, if you think about a parabola, I'll draw a quick sketch here. We could have our graph cross twice, we could have our graph touch the x-axis once, or we could have our graph not touch it at all. So those are our three options: 0, zeros, if that makes sense, 1 0, or we could have 2 zeros. Let's take a look down at these three problems. So find the zeros of each quadratic function, then check your answer. So if you're given a graph, don't make it harder than it is. Your graph, your zeros are simply where it crosses the x-axis. So here we would have negative 1 and positive 2. If I go over to this one, my x-intercept, or my 0 of my function, is simply going to be at 1. And if I take a look over here, you notice it never crosses the x-axis. Therefore, there are no zeros of the function. Whenever you check your work, what I want you to do right now is plug in negative 1 for x, then plug in 2 for x, and see if your equation, remember, it is where the function equals 0, see if this equation is true. So take a few seconds, do that, pause the video. And if you take a look here, we will see here are check steps. If you want to pause this and double check that yours is correct, if you notice, plugging in 2 results in 0, 0. Plugging in negative 1 results in 0, 0. Plugging in 1 over here, 0, 0. 0 equals 0. And then over here, it does not cross the x-axis, so we do not have a 0 of a function. Now, the second part of this lesson is finding what we call an axis of symmetry. An axis of symmetry is essentially a vertical line that divides a parabola in half. So here's my parabola. My axis of symmetry is simply this dotted imaginary line that chops my parabola in half. Now, the axis of symmetry also goes through this point right here, which in case you have not seen yet, you may have heard it, is what we call the vertex of the parabola. It's the only point on the parabola that does not have a partner. Every other point, if you think about it, here's one, here's its partner. Here's one, here's its partner. Here's one, here's its partner. The vertex is the only one that does not have a partner in terms of the symmetry. Now, if you end up having 1 0 of your function, you're going to simply use the coordinate of the vertex. So here, our graph 3 comma 0. Therefore, my axis of symmetry is x equals 3. If you recall from chapter 5, a vertical line has an x without a y. So in this case, we have x equals 3. Quick refresher, if you have a horizontal line, that means y equals something. Maybe y equals 3 or y equals -7 or whatever it might be. But with vertical vertical lines, this is what we are going to look at, an x without a y. If you have two zeros of the function, you're going to use the average of the two. So for example, here's 1, 0 at -4. Here's 1, 0 at 0. -4 plus 0 is -4. You chop it in half. That's what we mean by the average. You're left with -2. Therefore, if you see right here, it is simply in between the 2 points. Now, you could actually do that with any 2 points that are symmetrical to each other. For example, this point right here and this point right here, if you notice, the average is split right down the middle. Same exact concept. But the zeros of the function are usually the ones that are a little easier to see. So that's how you find the axis of symmetry, by using either the coordinate of the vertex or the average of the two to find the coordinate of that vertex. Now let's find the axis of symmetry of each of these parabolas. So in this case, like we said, there is only one here, 1, 0. So we can simply say that we are trying to find the vertical line's equation through 2. So all I would need to do is simply write x equals 2. Because, once again, remember, my vertex ordered pair is 2 comma 0, and it simply takes the x value. Over here, I have an x-intercept, or a 0 of -1. I have also an x-intercept of 5. I add them together, divide by 2. And, I'm sorry, this is +1. What am I doing? And +1 plus 5 gives me 6. 6 divided by 2 gives me 3. As you can see right here, that is right where my parabola is chopped in half. My equation of my axis of symmetry would be x equals 3. So those are the two methods that we just looked at on that previous slide with the two rules finding the axis of symmetry. Now, finding the axis of symmetry by using a formula. This is actually the one that you're going to use most often, because not always are you given a graph that you are just simply able to look at and find the axis of symmetry. The formula that we're going to be using is x equals -b over 2a. Now keep in mind that is for a quadratic that is in the form ax squared plus bx plus c. So I'm going to simply go through and find out what my a is, what my b is. C is not going to be used in this, but just for future reference, you will be using C later on when it comes to the quadratic formula, something you learned in section 9.9. So let's take a look at a quick example over here. I'm going to go ahead and first of all identify my values. A is 2, B is 4, and C is 1. So moving down, I'm going to apply this formula here, and I'm going to say -4, x equals -4 over 2 times a, which is 2 times 2, x equals -4 over +4, and then I see that my axis of symmetry equation is x equals -1. Now the other nice thing about this is that x equals -1, that means that your vertex is -1 comma something, because remember, if you're on a graph and you are going through your vertex, your axis of symmetry, that's where it splits it in half. It has to go through that vertex, the only partnerless one on that graph. So I would then take my -1. I'm not going to do this now, but I could plug it in for x, plug it in for x, and I would get my value. Actually, you know what, here I will do it for you quickly. 2 minus 4, -2, plus 1. So my vertex actually would be -1, comma -1. Let me double check this. 2 minus 4, yep, -1, comma -1. So that's how you can find the axis of symmetry, by using the formula. Now, what I want you to do is go ahead and pause the video and try to find the axis of symmetry of this graph. Y equals x squared plus 3x plus 4. Identify A, B, and C, and then go ahead and plug and chug. Go ahead and pause. And if you take a look here, you should have got your axis of symmetry to be x equals -1.5, or if you wanted to write it as -3 halves. I prefer x equals -1.5, simply because it is directly in between -1 and -2. So notice over here, A equals 1, B equals 3, C equals 4, and then all it is some plug and chug. Let's take a look at this equation. Once you pause it for a second, and go ahead and find the axis of symmetry. And here you go. Once again, A equals -3, B equals 10, C equals 9. Now, if I asked you to find the vertex of either one of these, you would then need to take this value, plug it in for x. You'd need to take this value, plug it in for x here, or both of these x's, and then solve for y, and that would give you your vertex, your x comma y. All right? Now, couple steps in finding what we call the vertex of the parabola. And I kind of just went over those on the last slide. First of all, find the axis of symmetry using the zeros or the formula. You can only really use the zeros right now if you are given a graph and you have the zeros right there in front of you. We'll teach you different ways to do that later on in Chapter 9. Then substitute, aka plug and chug, x in to obtain y, and then write the vertex as an ordered pair. So let's go ahead and try one here. Let's go ahead and identify my A, my B, and my C. Now in this case, it is actually C equals 0. Once again, not necessary now, but will become beneficial later. So now I'm going to say the opposite of B, which is 3 over 2 times A. So my vertex comes out to -3/2, and I'm going to, actually I can just leave it as that. Now I'm going to go ahead and take -3/2, plug it in for x, plug it in for x. It's going to be a fairly ugly number, but it's going to be the opposite of -3/2 squared. Very important, make sure you use your parentheses effectively here, because if not, you're going to accidentally get the wrong value. Let me double check to make sure we set everything up right here. The opposite of -3/2 squared. -3/2 squared is 9/4, which is -9/4, and then plus 9/2. And got a couple options here. I could rewrite positive 9/2 as 18/4 if I wanted, and then y would be 9/4, which could also be written as y equals 2 1/4. So then I could go ahead and write my coordinate. I have y, I have x. I can write my ordered pair as -3/2, comma 2 1/4. And that would be my ordered pair of my vertex. Not all of them are ugly like that, but because this was a fraction, we knew that it wasn't going to be very pretty. All right, let's take a look at where you see some parabolas in action here. In this case, we have the height of a small rise, and the Phantom's Revenge is modeled by this equation. So in physics, you can set up equations of parabolas like this, and you can chart their progress along the line. X represents the distance in feet from a support pole at ground level. Find the height of the rise. So essentially what you want to do, if they say find the height of the rise, we want to find the zeros of my function, and then using your vertex, or find your vertex, A equals 0.07, B equals 0.42, and then I can go ahead and use my vertex formula. Go ahead and take a few seconds to do that. Pause the video. Once you find your x value, you're going to get over here, if you notice, x equals -3. So that means it is 3 feet to the left of the support pole at ground level. Find the height of the rise at this point. So I go ahead and take -3, plug it in, and I end up getting the height of my rise, which is the y value of 5.74 feet.